Hello and welcome. In this video, we're going to cover Chapter 5, Number Systems of the CCNA Introduction to Networks curriculum. So let's get started. So the objectives of this chapter, things that we're going to learn, guys, is the calculation of binary to decimal, or the conversion between binary to decimal and hexadecimal as well. So let's get started. So binary numbers. So let's look at the binary numbers. Binary numbers are base of 2. So base of 2. So as you can see here on the table, as you can see, 1, 2, 4, 8, 16, 32, 64, 128. You may say, okay, from where those numbers came from? They came from the base of 2. So I'm going to grab my pen here. Okay, so let's use red color. Okay, so as you can see here, so this is 2 to the power of 0. So base of 2 means the 2 to the power of 0. Decimal is base 10. 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, and so on. 2 to the power of 0 equals 1. 2 to the power of 1 equals 2. And 2 to the power of 2 equals 4, as you can see, and 2 to the power of 3 equals 8, 2 to the power of 4 equals 16, and 2 to the power of 5 equals 32, 2 to the power of 6 equals 64, and 2 to the power of 7 equals, 128. The 0 here is the bit position. So for example, let's say we have 8 bits. Let's say we have 0 in decimal converted into binary is 8 zeros, right? So 0, 0, 0, 0, 0, 0, 0, 0. The bit position starting from here, this is the bit position number 0. 2 to the power of 0 equals 1. 2 to the power of 1 equals 2. 2 to the power of 2 equals 4. 2 to the power of 3 equals 8, to the power of 4, 16, to the power of 5, 32, 64, and 128. I think you get the idea. So, for example, let me bring a black screen here. Let's go to, go to black screen. And then let's say we have an IPv4 address. The IPv4 addresses, by the way, they are actually 32 binary bits, and they are written in decimal. So for example, this IP right here, or this network right here, okay? So each octet, this is called an octet. Each octet is 8 bits. So 8 plus 8 plus 8 plus 8. The total number of the IPv4 is 32 binary bits. See what I'm going to do? I'm going to actually convert the 0 from decimal to binary. So I'm going to write 8 zeros. So each byte, each octet is a byte equal byte, and the byte is 8 bits. I'm going to write the binary bits since they are 8. I'm going to write them right here. So 8 bits. So we have 8 bits. And then starting from the this bit right here, bit position is 0. So 2 to the power of 0, we are using binary. So binary is base 2. So binary base, 2. Decimal is base 10. 10 to the power of 0, and so on. Hexadecimal, hex is base, 16. So 16 to the power of 0, and so on and so forth. So to the power of 0, the bit position number 0 equals actually 1. 2 to the power of 1 equals 2. Okay. 2 to the power of bit position number 2 equals to the power of 2 right here. Sorry, let's go back. Let's go back to my screen. I think it's gone. Let me grab another window. I'm sorry for the inconvenience. So let's go and grab another window screen, black screen here. So let's say 192.168.1.0. I'm going to write the 0 in binary. Here we go. 2 to the power of 0 equals 1. 2 to the power of 1 equals 2. 2 to the power of 2 equals 4. 2 to the power of 3 equals 8. 2 to the power of 4 equals 16. 2 to the power of 5 equals 32. And 2 to the power of 6, 64. And 2 to the power of 7 is 128. You need to remember those numbers on the top of your head for the CCNA exam. So if you are preparing for a CCNA exam, please remember those numbers and you know from where they came from. So we use the 2 to the power of the bit position so we can get those numbers right here. So since we get those numbers, for example, let's say we have a number 200. So I want to convert number 200 from decimal. 200, as you can see, it's decimal, and we want to convert it to binary. So what we're going to do, the first thing we do, we ask how many 128 inside of 200, and the number is how many 128 inside of 200. It's 1. I'm going to write the 1, and then I'm going to subtract the 128 from 200. The result is 72. So 72. And then I'm going to ask again 64. How many 64 inside of 72? It's 1. And then I'm going to subtract the 64 from 72. The result is 8, as you can see. So how many 32 inside of 8? 0. How many 16 inside of 8? 0. How many 8 inside of 8? It's 1. And the remaining is 0. And then I'm going to ask how many 4 inside of 0? 0. How many 2 inside of 0, 0, how many 1 inside of 0, 0. And that's the binary number of the number 200. That's exactly what you do if you want to convert, okay? Convert to, okay, binary. Okay, it's a little bit, you know, complicated in the beginning, but you will get there. So, yeah. Converting from binary to decimal, from binary to decimal, it's easy. So what you do the sum of the bits that are turned on. So 128, so turned on, plus 64 turned on, plus 8 turned on, and this equals 200. You get the idea? So it's easier to convert from binary back to decimal, okay? And to convert from decimal to binary, you use this method as I showed you right now. Let's actually talk about the hex. So I'm gonna go and erase everything here. I'm gonna write the base of 2 on the top. So I'm gonna grab my pen. I'm gonna write 1, 2, 4, 8, 16. 32, 64, and 128. So for example, let's say we want to actually convert number 254, for example. So I'm going to ask how many 128 inside 254. It's 1, and then I'm going to subtract 128 from 254, get the result, and then ask how many 64 inside that result, and so on and so forth. Converting from binary to decimal, it's easy. You do the sum of the numbers that are turned on. And let's move to hexadecimal. Hexadecimal numbers are basically from 0 to 9. Numbers from 0 to 9 and letters from A to F. Okay? So A equals 10. B equals 11. C being 12. D equals 13, E equals 14, and F equals 15. 15 here. So, yeah, I'm sorry for that. So, yeah, let's go back. Don't think so. Let's go back to the, yeah. Let's go back to my screen back. Yeah, touching my pen. So let's say you want to convert, we talked about the A to F. 0 to 9, and A to F. Okay, so A equals 10, B 11, C 12, D 13, E 14, and F equals 15. Okay, so for example, if I want to convert A2, for example, so each hex digit represents 4 binary bits. Each hex digit represents 4 binary bits. That's the rule to remember, okay? Converting from hex to decimal binary. So you need to remember that each hex digit represents 4 binary bits. For example, A being 10, so I'm going to write the 10. I'm going to write the base of the 2 on the top right here. 1, 2, 4, and 8. So we have 4 binary digits, right? So A equals 10, so there is 8. There is no 4, there is 2, and there is no 1. That's the 10 in binary, or A in hex, okay? So 2, it's 4 digits. So I'm going to write the base of 2 on the top. 1, 2, 4, 8. There is no 8. There is no 4. There is no 8. There is no 4. There is 1. There is 2, and there is no 1. And that's the A2 binary number. So if you want to convert from hexadecimal hex to decimal, always convert hex to binary, and then convert the binary number by using the sum, of the bits that are turned on, so you can get the decimal number. And remember, the hexadecimal digits represent 4 binary bits. So each hex digit represents 4 binary bits. Okay, I hope this has been informative for you, and I would like to thank you for viewing.